Alright, we're going to make, this time, an amplifier. I've got here an old box from something that came from the 20s. Transformer. I don't know what this thing was originally. It had a rheostat and a few terminals on it, and that was it. It didn't have any functions or anything else. So what we're going to do is convert it into a nice amplifier to take a signal from a crystal radio and make it to where it will operate a horn speaker. Now the tube sockets on this support, it has this support that mounted on the front panel like so, and these are old UV 199 type of bases. Okay, I've got some of these bases, and that's what we'll use to make the tubes. Okay, so we'll just have two tubes that'll sit in there. One will be a voltage amplifier, the other will be a power amplifier to drive the speaker. Okay, we'll clean all this up, of course. A rheostat for the filament, the transformer, interstage transformer. Okay, so what we have to do is make up two tubes. Okay, first thing we're going to do is go ahead and make up the envelopes. In the end for the ceiling stem. Alright, now I need the diameter for the base of the tube. Right on there. good. It's perfect, okay? All right, we need another one. Looks good. Okay, I'm cutting the wires now for the electrodes. We have copper wires for making the leads, and then we use nickel for inside the tube. Okay, I've got 2, 3, 4, 5, 6. I need 2 more. That's 7, 8. Okay, this is nickel cathode tubing here. We take it out of tubes. We get that cathode sleeve, and it's a piece of nickel tubing that's very thin. It's like less than 1 mil thick. It might be 1 mil thick, and that makes a welding junction. See, if we put that nickel on there, when we heat it with the pincher welder, that nickel melts and it fuses to the copper and fuses to the tungsten. If you try to fuse copper straight to tungsten, it will not fuse properly. You have to use special techniques to make it work because of the oxides that are formed. Don't know if you can see it. See, we've got the little piece of nickel right on the end. Okay, I'm just pinching these down on there. Just crush it a little, make it flat. If you try to do 2 round things, you can't get them together. Round on round doesn't line up. Next thing we're going to do, we're going to put the tungsten onto the nickel, okay? For the actual feed-through wires, I need to flatten them a little bit so we can easily, by making them a little flat, it makes it to where when I hold the tungsten wire onto it, it's really easy to hold it on there. If it's a rounded surface, you can't hold anything on a rounded surface. I'm a supervisor. Beautiful weather right now, so she's in having a good time. This is 9 mil tungsten that we're using. That will make the seal through the Pyrex. Okay. Mention here such that it will fit into the hole. If we can't get it up in there, we're out of luck. Support, 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 support. 1, 2, 3, 4, 5, 6. We're going to need 7 wires going through on that one, okay? Oh, you little baby. Here, come and say hi to everybody. Here, say hi to everybody. Here, look up in the camera and say hi. Okay, now we go to high power. For here, we're using the full 90 amps because we want to make sure that we fuse that. We want to fuse that copper and nickel onto the tungsten. And if we don't use high power, it will not make a good joint, and we'll have it come loose when we do the glass work. The thing really buzzes when it has that 90 amps going through it. Okay, and we use this crimper here. Okay, and that gives us our finished feed through. So this part here with the copper sticks out the bottom, and that goes into the socket holes. So we got to have that being, that has to be copper so that we can put it through the hole and solder it. We can't solder the tungstens. Tungsten does not solder with lead solder. And then up inside the tube, we're going to use the nickel because it's a much easier to weld than the copper. If we used copper up inside the tube, then we'd have trouble welding the elements onto it. So we make it a three-part electrode like this. It's a pain in the neck to do, but the success rate for doing it this way is very good. Very rarely have a leaker doing it this way. Very rarely. Okay, that gets our 4, and then our 2 supports. That's 6. So that makes our sets of electrodes for the 2 tubes. Okay, now to hold these while we do the glass work, when we pinch them, we use pieces of this duct tape. What you meowing about? What you meowing about? What? What you meowing about? There we go. Okay, I'm going to do the small one first. Okay, I'm going to put that is going to be plate connection. Okay, grid support. Okay, that's filament connection. Okay, filament connection, and then we're going to have both filaments on the inside. Okay. Okay, filament connection. Okay. Then grid connection. All right, and then plate support. And then we bend those over. Okay, now that will hold the wires in position when we do the pinch. We'll slip it up into the glass and then pinch it down on there and melt it onto there, making the seal. Okay, that's one. Okay, we have a carbon blade up in there. We're going to make the slot for the pinch. First thing we have to do, oxidize the tungsten slightly. We're going to heat the nickel up, drive the air out of it so it doesn't bubble when it goes into the glass. Okay, well, just pinch the wires so I don't burn them when I heat the glass. Okay, I'm going to clamp the wires. Okay, the wires are now clamped in the glass. Okay. Okay, now I'm going to do the actual pinch. Heat the glass very hot. Do the pinch. Okay, that's the seal pinch right there that I just did. Okay, now I'm going to clean up the edges. Okay, and we got one seal. And there's our pinch. Okay, hopefully we'll test it in the leak detector, make sure it's good. Alright, got the leak detector going. We got the first seal on the inlet. Alright, we'll go ahead and fire it up. Okay. Okay, we need a little water. Okay, we'll turn on the helium. Alright, got little bubbles there. Okay, now we'll set this Okay. I'm just blowing the helium down into the area where the seal wires are. We're getting no movement at all. We're on the most sensitive scale of the leak detector. Okay, so this one's good. Okay, shut the helium off so I don't lose it all. Okay, that one's good. Okay. Here we have our plate. This is a 5Y3 plate. I just took it out of a 5Y3 tube and cut it down to where it's going to be the right size to fit in our envelope. Okay. Now, for the grid, we got to make up a grid that'll fit. I tried finding one, but there just isn't any that's going to be the right size. I mean, they either have too fine of a pitch. See, if you have that fine of a grid pitch of the wires, then it's going to take so much B+ voltage to make the tube work that it'll be out of the range that we want. It'll take 150 to 300, 250 even, maybe 250 volts, even 300 volts to make the tube have a decent emission. So what we're going to do is we'll make the grid ourselves. Okay, I'm going to make a frame that will go up inside here, and we will weld the grid wires onto it. A frame that has the thickness that we want the space of the grid to be, and that'll fit right up inside here just perfectly. Okay? Now, for the grid wires themselves, we're going to use this nickel wire. This is 10 mil nickel wire, and we're just going to take that and weld it on there for the grid. And we can make the spacing enough to where we'll have no trouble at all with the B+ voltage. Okay, to do this, we have to use a different... okay, we've got two different welding machines. This one down here is a capacitive discharge welder, whereas the other one is a transformer welder. This one just a brute force. It has a transformer in it, and you just put that 60 cycle power right in. But even 1/2 cycle of power of 60 cycles is enough to burn through this thin nickel wire. You know, it'll just burn through it and make it to where it doesn't weld. It just cuts it. So what we have to do is use a capacitive discharge unit, and it will go ahead and make the weld without any danger of burning through at all. See if I can figure out how to get this connector on here. There we go. Now, got us a separate pincher here for it, and it uses the same foot pedal as the other one. Okay. All right, let's try 33 volts. That's 33 volts. There's a 100,000 microfarad capacitor in there at 50 volts, and that's what we use for the energy storage. Okay, I'm going to make up some straight pieces of this nickel wire by stretching it. See if I just take that and stretch it. Okay, see, that makes it perfectly straight. Okay, we'll cut that. Okay. All right, that's a little bit hard to handle, and we'll cut it in half. You can get this nickel wire on eBay for it's a roll like this is 50 cents. It's a 100-foot roll of 10 mil nickel wire. Very, very low cost. Okay, now we'll take that and we'll see how it works. Okay, foot pedal, and we're ready to go. Too much, too much, too much. All right, I'm going to set the voltage down Okay. I've set it to 20 volts. Let's see what that does. Whew, that's a lot of bang coming out of that sucker, huh? 20 volts. Okay. See there? Perfect weld. Okay, other side. Okay. Nothing to it. Okay, so 20 volts is going to do the weld perfectly. Yeah, I bent the wire all to hell. Okay, now I'm going to put these just a little more than maybe about a 1/16 of an inch separation. Okay? Isn't that something? Just that little bitty spark is all it takes to weld it. If you're going to match tubes, then you've got to do a little bit more critical spacing on the wires. But since I'm just making one tube, I don't really care what the exact characteristics of the tube are. We just want it to amplify. Okay? Okay. Okay, and there's our grid. See, and that will fit perfectly right up inside there. It fits, it'll be perfect. Okay, next I need to cut this top off of here. And I got to be careful, otherwise if I just cut it with the pliers, the stress will break this loose. So I'll use the Dremel tool. Okay. Okay. Grid assembly. Okay. And that goes up inside. We have plenty clearance. I go right up inside there. Perfectly. Okay. So that gets our plate and our grid assembly made. The next thing we got to do is we've got to put the filament in. Now, on this particular tube, we're going to use a hairpin filament. Two connections that go to through the glass to make electrical connection. Then we're going to have a center post going up with a little V shape in it. We'll make a little, the post will come up and we'll have a little V cut like so. And we can put that filament wire in there, and that'll keep that wire in place. Okay? So the first thing we do is we, 3, 6, that's the wrong one. I want this one here. Okay, first thing we have to do, determine the length of that center post. Okay. Now, the grid, see that grid is going to weld onto those two, and that'll hold the grid. And then the plate will go down over the whole thing, and it'll be welded to the two outside ones. Okay? But right now, what we have to do, okay, let me see where the envelope is. Get the height. Let's see what our height is here. Okay, we're good on height. We have a good 1/2 inch on the top to play with. Okay, so I'm gonna cut about a 1/4 of an inch off of the filament. Okay. Now, these two here are the filament connections, I hope. 1, 2, yeah. Okay, so I'm going to cut a 1/4 inch off of here. Okay, now what we're going to do is we're going to flatten this so that we can make a slit in it to where we can get our little notch for the filament wire to go through. Okay, I'm just going to take that and hit it with a hammer off camera. Okay, see how we flatten that out? Now I'm going to go on the diamond saw and I'm going to cut a slit in there, just a small slit, and that's where the filament wire will go. Okay, I'll be right back. Okay, see there? So the filament wire is going to be welded to here, come up over there, and then be welded to the other one. Okay, I got to get those filament connections bent into position. Okay. All right, that will do perfect for that one. Okay. Okay. Okay, this is the 3/8 tungsten wire. Oops, that's a good move. Bang into that. Okay. Whew! Ha! Wacko! Okay. Okay, now that wire comes up. Bend over the top. We'll come down to the other side. Well, that didn't work. I wasn't pinched right. Okay. There we go. Okey-doke. There we go. Okay. See how that is? Okay. Now, the grid, go right down over it. Okay. 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 I am ready. All right. Okay. That's on there. There. Okay. The grid is welded on there. Okay, now the next thing I have to do is adjust the positioning of the filament so that it's perfectly centered. The bottom of the filament is perfect. It's absolutely perfectly aligned. Okay? Now, the next thing we have to do is get the plate in there. Okay, I got to bend those straight up. Goes here, right down between it, and it looks very, very good. Okay. It's on there good now. If I could just get it aligned, we've got it. Okay. Got the excess here. Cut it here. Cut here. All right, that's good. Now, I have to bend. Okay, I have to go that way. Very good. And I have to go that way. Wow. Now I have to here. I have to go way over. Okay. We're good on that. Now what I have to do is get the getter into position. And I'm going to weld the getter onto the plate. Okay. All right. Around here. Get your foot over the pedal. Okay. All right, so that puts the getter on there. Now, we have to bend that around to aim it downwards. So we want that getter to flow down into the bottom of the tube. Bend that up here. Okay, now, if that's here, okay, see, that'll just flash the getter right in that area. We're ready to seal the tube together, okay? We're going to go and we're going to seal it together, and that will be the first tube. Okay, let's go. Okie doke. First, we're going to warm the tube up with the annealing torch. I have no idea how good this getter is going to work. This is a brand new type of getter. I've never used it before. Okay, that's good enough, okay? Alright, that's hot. Now, I gotta position it exactly the way we want it. Boy, that looks good. I've got to go this way. Okay, now I'm going to go ahead and heat one point and get it stuck on, okay? Okay. Okay. That looks good. Okay, now we'll get the other side. Once we've got it stuck on there, then we can go ahead and work on the rest of it. Okay. Now the glass cannot move when we work on it. Just going along here, sealing the glass. Okay, now I'm going to use the pressure to just blow that out and make it neat. Very good. Okay, now we just let that card cool a little bit and we get it over on the vacuum system. See, right now we're at the worst possible for the getter. We got it roaring hot and we got air in it. So the getter is reacting right now very significantly to it. All right, first thing we do is we test it for leaks. Perfect. Okay, we're ready to pump her down. Okay, that gets our bake-out oven on there. We set that to 500 centigrade. It's 1,000 degrees Fahrenheit. And that'll bake the tube out. It'll take the diffusion pump about 20 minutes to get it down to down in the 10 to the minus 5th range. Alright, that gets our wires hooked up. Okay, next let's give it some filament. Okay, filament is lighting up nicely. Okay, now let's see, I'm going to put some plate voltage. Okay, 67 volts. Ooh, look at that. That's got good gain. Look at that gain. Woo! That's a gain of 400. Okay. That looks good. Okay, that's with about 3.5 volts on the filament and 30 volts on the plate. It's 45, it pegs out. I mean, that sucker has got some good gain. Okay. Alright, next thing to do is to flash the getter and seal it off. See, I'm just heating it up red hot to drive the gas out of the getter itself, and then the pump pumps that away. Okay, seal her off. We got a hailstorm going on out there. That's what that thumping noise is. Hail hitting the air conditioner. Okay, there's our tube. Okay, all right, we've got to take care of this box. Okay, first we're going to just clean the old varnish off of it. It's completely dried out and pulverizing, so it's easy to get off. We're just taking a sharp chisel and dragging it across it. Go with the grain, and it just takes that varnish right off. Inside is not as important as the outside, but we are going to make it look good inside too. Okay, we got to get this thing stained. Okay, we're just going to use dark walnut stain. This cheap hardware store stain. It's nothing expensive. Little piece of felt. Oh, that's going to look good. Oh, that's going to look good. Oh, yeah. That looks just gorgeous. Got that nice, beautiful, dark color to it. Okay. Set that aside to dry. All right, I got an old radio panel here. I'm going to just use it to make the piece. Okay. Neat. All right, let me bandsaw that out. Okay, looks good. Okay, now I'm going to belt sand. Alright, that gives us a piece of panel. We got a couple of extra holes here. These two I think I can probably use. This one I'm going to try to cover with a knob. Okay, now for our panel, okay, we got two holes. We got one of them up here, the other one about here. So we can put terminal here. We'll put another terminal here. Okay. And we'll go on the other side, same place. Okay, this will be the in, this will be the out. Okay, so what we're going to do is we're going to put our rheostat right in the middle. And then we're going to go, and this will be ground, and this will be filament. I may as well not even use a ruler. That's it. That's all we need. Okay, I will go drill them. Okay, that looks good. What I'm going to do, I just need a little solvent. Okay, this is just lacquer thinner, and I'm just going to wipe this off. Ooh, it's dirty. Looks really good. Okay, I'm going to buff it. Get me a clean rag. All right, that looks excellent. You can fix this with these wires hanging like this. They're going to break off, screw everything up. So, give me here to supervise. Did you come to supervise? Well, you're not going to say hi to everybody? Not even going to look in the camera? Come on, look in the camera. All right. See, if I wiggle my fingers, she might look in the camera. He's going to sit there and take a bath while we do work. Oh, she's so cute. Okay. Okay, a few minutes on the lathe. And we've got some push-in bushings. These are just pressed in very firmly, and they're tapped for 632. So that will give us our insulated terminals. Okay, let me get some screws. It's on there. Okay. It takes that transformer and makes it to where it'll last forever. Okay? Alright, the next thing we're going to do is start assembling over here. It should be in the center. Okay. Transformer in. Our transformer goes right here. Okay. There's a transformer and our rheostat. Okay, I got other terminals. This one here is severely damaged. Two more. In here. There. The minus and there. Okay. It's meant to be a shock mount. But the old rubber, I mean this rubber, it's hard as a rock. Alright, I need two more of those. Okay, we'll put this on first. Okay. Okay, now let's try again. Hopefully it's going to fit here, okay? All right, so the first thing we have to do, we have to hook all the grounds together. Okay, see, that'll be there, there, okay, and this transformer. Okay. And we're going to do all of this with the old-fashioned 20s solid wire type of wiring. All right, we got the amplifier connected up. We've got the signal generator going here, and we've got our power supply connected up, and we got our horn speaker connected up, and right now we're putting an input signal. Let me get the scope going here and we'll see what we're putting in. It's not much. This thing doesn't have much gain compared to, alright, so I got a chart here that shows what this generator is supposed to be putting out. It isn't even in the ballpark. Oh, yeah. It was a free generator. I got it for free, so no telling what it has wrong with it, if it has anything working on it at all. Okay, I'm going to put 50 millivolts in. That's 50 millivolts peak to peak. All right, that's adjusting the filament for maximum gain. Okay, it works best with 45 volts on it, which is good. And we're running 6 volts at 2 amps. Okay, that's not too bad. Alright, now the next thing we need to do is connect a radio onto it and see if it does any good. Alright, I will get a crystal radio and we'll see what it does. Now, we cannot run this open. If we hook it onto here directly, it's going to be open circuit, so we won't get any current through the crystal. That's no good. We have to have a load here, so I'm going to put a variable resistor here, because I don't know what the optimum load will be. First, I will connect the scope onto the crystal radio, and we'll see that we do get a good signal. Okay. Ooh, yeah. Okay, that's 50 millivolts per division right now. I'm adjusting the sliders on the coil. Okay. Okay. That looks like the best right there. It's about halfway. Okay, now let's connect some wires over to the amplifier and see if we can hear it. That's a lot of signal right there. I mean, that's a good 100 millivolts peak to peak. But when I connect it to the amplifier, You can hear the damn thing there, but it is just barely there. Oh, what a bummer. 2 tubes is not enough to do much. Oh, well, so much for that. Let's see if I get over there, you can hear it. Okay, well, you know, hey, nobody said it's going to work. It was just a project to do. Okay. So it's not going to really do very good for a crystal radio. It needs about 100 times more gain. Okay, well, hey, you know. All right, the next thing to do is we've got to spray the box with lacquer. So it has a gain. It's going to take about a volt of input to really drive it to run the speaker good. So it doesn't really have enough gain to work for a crystal. Oh well. All right, let's go spray the box. Okay, that's going to be it. That's it. Alrighty. All right, the only thing left to do now is labels for the various terminals. All right, now here we have our labels put onto a piece of transparency, and they're not just right. What I have to do, I'm going to put them on a sheet of brass, and that'll make them look really nice. This is just stickum, you know, spray stickum glue, contact cement. That'll do it. All right, we're going to let that dry for about 5 minutes, and then we'll stick it on there. Something to look out for. When you go to get the transparencies, get the perfectly clear transparencies. These have a little bit of a milky look to them, which is just, it detracts from the appearance. And it's best if you get the ones that are absolutely transparent, clear. Now, I got carburetor cleaner here. This is stuff that doesn't leave any residue. Don't use any solvent that leaves residue. You can't use any soap or anything like that. Any of these so-called eco-friendly solvents that are just nothing but soap and water, because they'll leave a residue and your glue won't stick. All right, this absolutely, see, it takes off everything and doesn't leave any residue. All right, we got super glue, And we're just going to stick these in the right position here. Of course, drop the damn thing on the floor. Oh, hell. I keep trying to blame it on old age, but I think it's just I'm a klutz. I'm just a klutz. Okay, try again. Can I get it on there without dropping it? Okay, that one goes right there. Now, something very important when you're putting these labels on. Make sure they are exactly parallel to the edges of the thing. Nothing looks worse than to have them at a slight angle. So make sure that you pay very close attention when you put those labels down so that they're perfectly true to the edges. Because it really looks crappy when they're at a slight angle. Okay, those will harden in a matter of minutes. Now, one of them I forgot was a label for the whole amplifier. I'll make that up. Look nice. Okay. Here's our finished amplifier. The box turned out just absolutely beautiful. Then inside, yeah. So you can see down inside there where our tubes are. And that's it, a 1920s tube amplifier. That'll go in my collection. All right, that's it.